originally I wanted to do a robot, like, so I had in mind, like, I want to do some sort of robot. And originally what I wanted to do is a robot that kind of like drove around the school and kind of like plugged itself in, and like it was like autonomous. I thought it'd be pretty cool. But then I started talking with a guy over at Teletech, Dan LaRoche, and you know, he told me, he's like, okay, well, it's a great idea, like it'd be really cool, but it's going to take you way longer than 1 year to complete. And so he's like, why don't you like simplify, you know, like I like the robotics idea, you know, like why don't you simplify a little bit and focus in on something that's like it does like basically one thing, and you know, you're going to be able to finish that a lot more easily than trying to do a million things all at once and not finish any of them. You know, I'm glad I took his advice, because, you know, doing just the robotic arm right here, I mean, it took all year, and it was really tough. So then the next part of like my design phase, you know, like I took the summer off, like we didn't do anything over the summer. Came in first trimester and started doing lots of drawings and like CAD drawings, doing some research on like what I can do, what I can't do, you know, I came up with, I was almost done with completing my design, and then I realized I couldn't manufacture anything. I had just drawn on the computer, because you know, like I sent emails to this company that like they make metal pieces, and like, oh, we don't do it for this for like one piece, like we only make like thousands of pieces at once. So then, you know, we're part of the VEX robotics team, and so I saw that they like made an announcement, like they're releasing the new VEX Pro line, and I was like, okay, I'll go check this out. And so what I found was that they have a lot bigger parts that are for more professional robots that I could use. And so then I checked them out, and you know, like they were priced very competitively versus everyone else. It was a lot cheaper to get. You know, like so, like this motor here was about $20, and anywhere else it was $150 for something that size and like that big with that many teeth. So finding them, like that was a lifesaver. Like, you know, finding someone that I could like their price for education, their price to like for projects like this, and so I started basing my design off of that. So I brought in a couple pieces that I want to show you guys. So like this is the axle that like it came in, I think that's 3 feet that it came in, so I had to like cut it up into pieces. So if you notice, it's hexagonal shape, and so obviously hexes, you know, you can put it into a circle, it kind of spins, but you know, not very well. And so they also had bearings that I can pass around, and so I put those into my design to help me, you know, like at all my joints, so like here, like all the way over around here, I can put them at my joints and free spin, so you know, like here, like this arm, I want this arm to stay still when this arm is spinning. So this one down here would be able to free flow, whereas this arm up here moved with the axle. And so that's what the bearings allowed me to do. And so, let's see. What do I do next? So then I started thinking about, you know, it had to be a pretty compact design. I wanted it to eventually kind of fit behind a wheelchair within, you know, I figured, okay, doors are whatever width, wheelchairs are a little bit smaller than that. So I went with about like a 2-foot window, was like the biggest I could possibly ever be. And I kind of squished it into that. So one of the things I did was to make it so I had smaller motors and like they weren't as expensive, was I used the chain and the gears, the sprockets to kind of move all my weight lower to the base. That way I could get one really strong base motor that could lift everything, and the rest of them could be a little bit smaller and be less weight. And so the way that works is, so you guys can all come check this out. So this is this motor right here controls this arm right here, and so the way that works is this gear and this gear are connected to each other. They touch, and they're on 2 separate axles. So the motor spins, and then this one spins a little bit slower because it's less teeth, and then on the same axle I have sprockets. You guys check those out. So these are the sprockets that I got. it's a really small sprocket, 16 tooth, and that goes across the chain all the way up to the big sprocket, which is 72 teeth, and that makes it so it spins slower, it's stronger, it's got more torque, and that allowed me to move all my motors down instead of having, like the motor weighs like a pound. So putting it all the way out here, you get a lot more force on the bottom axle.
Are those servos too?
No servos.
What's the box in the middle between the motor and the gears?
These ones? Oh, right. Yeah. So actually, those are gear boxes, and so I actually have a video I'll show you. So with those motors, I originally bought them. They're pretty strong, but the problem is they spin ridiculously fast, almost 30,000 revolutions per minute.
How many?
30,000. So you can see here, I made a website so I could organize like any pictures and parts and stuff I have. So here's the motor when I originally got it. There you go. It spins ridiculously fast. You can't really attach it to anything, so that's a problem. Let's see. How do I get back? There we go. And so I attached gearboxes, so you can see here the gearbox is attached to it now. So you have the black motor down here, and then the gearboxes are attached to it. So I don't know if you guys can see it, but right here there's three, they're little like joints, and basically each one has a specific gear ratio on the inside, and they're called planetary gearboxes. I'll see if I can pull up a video of how that works later if you guys want. But basically, it's all internal. It spins really fast down here and really slow up here. So like this one is a 10 to 1, 10 to 1, and then 3 to 1. And so you multiply them across and you get 300 to 1 ratio. So we end up going from like 30,000 all the way down to like 300, yeah, something really small. And then it gets even smaller because then I have this gear is a lot smaller and attaches to an even bigger gear, so it slows down a lot. So this one, you can see the label is 100 to 1, so that has two 10 to 1 ratios. And then the smallest one, all the way at the top, only has a 10 to 1 ratio. And so that was because, these ones had to be that big because of their, they could be big enough because there wasn't as much of a room constriction up there. But you can see all the way up here, I can't have a motor sticking out to here. So I could only go with the 10 to 1 with a smaller motor. So you can see the black motors they're a little bit bigger, they're a lot stronger than this small little DC motor I got. Okay, so then I'll show you the video I took when I was testing out the gearboxes.
Seamus, did you actually do all the math to figure out what your output is, or are you estimating it?
At some point I did that. I don't have it on here.
Alright.
But yeah, I checked out what the gear ratio is going to be and how much torque and force I'm going to be able to put on it. I know off the top of my head, I believe the bottom motor is something like 3,000 foot-pounds or something like that. Foot-pounds per inch. Which, it sounds like a lot, but those gears are small amounts of surface space pushing on each other. So let's see. Are we going to be able to get YouTube?
I can override it if you don't.
Okay. Yeah, I don't think that probably won't let us.
Trying to, but it's not.
Slowly.
Could be the browser. The browser needs.
Was it Chrome? It should work. We have problems with all browsers.
We have problems with technology in general. We can let it live. But basically what the video was just showing is, like I said, the motor spin at 30,000 RPMs. It shows how much slower it's going. So let's see what I want to talk about next. So that was the mechanical side of everything. I got all the mechanical gears, sprockets, pulleys, everything. That all worked out, fitted together. And then you know, I got my 2 claws up here. I got 2 claws for taller objects. You know, 1 claw, you kind of like, if it's like kind of tall, it can like tilt around and flip around and whatnot. So I figured, okay, I'll get 2 and I'll just kind of like layer them together. It'll give you a little bit more stability. So once I figured out all the mechanicals, you know, like that's pretty easy. It's not too bad. It's like, okay, gear ratios and like how everything connects, you know, it's kind of not too bad because like Vex Pro really helps out a lot. They have all their parts, you know, they kind of try and make them so they fit together. It was the electrical side that gave me the most trouble. As you can see here, this controller is not the same as this one. So originally, what I really wanted to do, I wanted to take, you know, a controller that, you know, you could use with one hand, and I wanted to try and like automate it a little bit. So, you know, you push forward and it like extends out, you pull back, it pulls back. You know, I wasn't able to get the automation because the budget kind of ran out, so I couldn't put any like sensors or anything on here, or like distance finders, or I couldn't afford to buy the motor controllers. So, like, you know, these are all spinning at different RPMs on the final parts of them. So, you know, if they all go full speed all at once, you know, they're all going different speeds, so it doesn't end up being straight at the end. So a little bit of the problem with the budget near the end, but so the difference was, like, you know, so I had that, I took it apart, you know, I was ready to wire it all in, but the problem was on the controller that I had, all of the insides of it, you know, like someone, whenever they manufactured it, you know, they had these really tiny wires because, you know, they didn't really have to do much. They were just kind of sitting there, like inputting push buttons and like potentiometers and whatnot. And so my problem was, as I went to connect it, these tiny little wires that I had soldered together were snapping. So, you know, earlier this week, you know, I'm trying to finish this, and, you know, they keep snapping, and then finally I was just like, okay. We'll get rid of the push buttons, we'll just take out all the potentiometers, and, you know, I went to Radio Shack and I got 2 extra potentiometers, and so basically what the potentiometers allow me to do is, as you come check it out. So here you can see this potentiometer sticking out. I drew a line here to show where neutral is. So basically when it's at neutral, it sends like a 2.5 volt signal to the Arduino. And the Arduino senses that as like 2.5 volts, and I told it when it senses 2.5 volts, do nothing. And then I told it, you know, when it goes over like 4 volts, that's when I want it to go forward. And when I put it below like 3 volts, or like when I put it below like 2 volts, or like 1 volt, or when it goes all the way to 0, I want it to go backwards. And so basically what the potentiometer allows me to do is allow me to vary the voltage, because it's a variable resistor. So, you know, as you turn it one way, the voltage goes up, and as you turn it the other, it goes down. So I used, let's see, 1, 2, 3, 4, 5, 6 potentiometers. 4 of them I got from the controller that I had. You know, I took it all apart. I put them on this board earlier this week. And then the 2 I just got from Radio Shack earlier. So that's how that works. And so you heard me just say Arduino. So basically what our Arduino is, you guys can come peek in here. It's this small little blue, it's called a microcontroller. And basically what it is, it's a little small computer that runs programs that I program for it. So, you know, I sat on the computer and a program, it's kind of like Java. It's kind of like a Java or like a C++ mixed kind of with like a BASIC. So, you know, there's some freedom to play around with it, and there's also not some freedom to play around with it. It's pretty good. So basically I program that to input the signals and then move, and then like you can see under it there's a bigger blue board, and that's called a relay board. And basically what happens is the Arduino tells the relays to switch, and they switch from ground to power. And so what will happen is, you know, I'll push up on this one, and then it will tell relays 1 and 2 to switch on. And it will let the electricity flow to motor 1 and make it spin like clockwise. And then I put it to 0 and it tells them to turn off. And then I turn it down and it tells them to go backwards. And so that's how you get the motion going.
Is that communication really slow? Because when you were trying to do it at the
It
beginning.
has
there was
a slight delay because what happens in the programming is it checks the analog signals and it goes through them one by one, checking each one individually. And so what happens is you could switch it, and it has to, and if it just passed that point in the program, it has to check all the rest of the program before coming back. So there is a little bit of delay with it, but that's more of a like programming / controller issue. You know, like the microcontroller doesn't work that fast, but like if you had a really fast processor, it would rip through it really quickly, and there'd be basically no delay. And then I'm not an expert programmer, but I'm sure there's a way to program it to do it all simultaneously. Because you know it is a pretty powerful processor. I think it's like a gigahertz or something like that. I mean, it's not that slow for its size, and so I mean, it can probably handle it all simultaneously. But no, I'm no way an expert on knowing how to get it to do that. So yeah, I have it, it's checking, so I'll check analog signal 1, is it above 3 volts, is it below 2 volts, or is it in the middle? And then it says if it's above, switch the relays on. If it's below, switch the relays reverse. So there is a little bit of delay. Let's see, I'll see if we got a picture that I want to show you guys, and then I'll do a little demo.
Is it lethal?
It can be.
That's Mr. McGowan. It wasn't working right.
Yeah, so here's a better view of like all of the gears and sprockets. You know, here's the big one versus the smaller one. And those are the big sprockets. Let's see. Oh, so here's a close-up on those little areas I saw, the like units I was saying. They give you labels so you can see like this is the 10 to 1, this is 10 to 1, and then it's 3 to 1. And so yeah, they multiply across, and then it goes up to 300 to 1.
So it's for every 300 times the motor spins around, the other thing spins once?
Yeah. And then it's geared down a little bit more. I don't have my calculator on me. But the small gear on this motor is 16 tooth, and the big one is 82 or 86, and so that slows it down even more.
It's like a 4 to 1.
Yeah,
5 to 1.
and so it multiplies again.
So
So it's like
And then-
1,200 to 1.
And you had the ratio of the gears too.
Yeah, well the very bottom one
sprockets, I
doesn't
mean.
have it, and then these ones, these next two do, yeah. So yeah, the gears, the sprockets make it slower even as well, because what happens is, you know, this might spin once, but this spins an eighth.
Yeah.
So it goes a little bit for this whole rotation going once. Yeah, so that's how the gears and sprockets and stuff work. Let's see. So originally, that's probably the so right here. So on the right, the bluish green board right here, this is a motor controller. And, you know, I was going to use one of those, but then what happened was it uses all of the pins on the Arduino. So I would only be able to run about 2 or 3 motors with it. And I wanted to be able to run more, so I got the relay. And then this is a USB to Arduino. And, you know, like, I was close. So, you know, I had it all ready to go connected. You know, all I had to do was program it. But then it was pages and pages and pages of programming. And I could not understand anything it was saying. And it ended up, you know, I did a bunch of research on it, and it ended up being that, you know, even though it was connected to a USB, you had to then wire it again to the computer. You know, I wanted it to be mobile. So, you know, having it hooked up to the computer to, like, translate the signals and then send it back to the Arduino just wasn't going to work. Let's see. I think that's it for pictures. So then, you know, fundraising, these are just like the sponsors I had. So, you know, I had a couple local people, and then most of the money came from the Hexbug sales and from both Winnicott, and then my mom brought some to her work.
So most of the money came from me, Connor.
Exactly. Okay, so I'll plug this in. We can do a small little demo.
We can shake someone's hand.
I don't think you can do that. It probably it
Can it feed me
it can
Cheetos?
rip someone's hand off.
Well, I mean,
Can we see it then? Well,
James, I
maybe
volunteered you.
if you rip Gosling's hand off, you can't write an F in the grade book.
Too late.
Okay. So this is the very bottom motor, so I'll move it up. And so then, like the next one. It's so it's a little too much force down on this one. So you know it can't hold itself up. That's fine. That way don't break that one. Let's see. Which one is it connected to? Alright, so it looks like that top one block, it's probably got broken. Well, see, what happened was the very top one, because it was only a 10-to-1 ratio, it was going ridiculously fast. I think Gosling was here when McGowan came in and he goes, BAM! So it was still doing that last night, so what I did is I got these large resistors right here.
holy crap.
To kind of step it down. It looks like they might have stepped it down a little too much.
What's the resistance value?
Well, they're only 100 ohms, but they're really big.
How many watts are they?
Like 20, like 10 or something like that. I mean, so it looks like it probably stepped it down enough that it's below the smallest voltage allowed on the motor, so it just doesn't spin at all. But, you know, you can. But basically, would have been able to stretch out and then activate the claw to grab something.
Does it forward?
No. It's I had to disconnect it because it was going crazy. So anybody got some questions for me?
So it's not lethal.
It's not lethal right now, but it can be programmed.
On your motors, could you have taken them and turned them horizontally to save more space, or would you not have been able to do that?
Yeah, well, I know what you're saying. You know, like just turn them sideways. The problem with that is, like then I have to do an axle that goes like the other way.
Oh, right.
And so then the problem becomes, you know, like where do you put the axle? You know, like then you have to build like a little something that comes off here and here, and then put an axle between it. And so, you know, I definitely thought about that. And then like the other problem is I don't think they have the gears that change the direction.
Oh.
Because you know, I mean, even if they did, it'd probably break it because there'd probably be a lot of force on
Do
those
they
ones.
have universal joints?
I
Because you could,
don't think so.
because if they did, you could mount it that way and put 2 joints and then have like a.
Yeah, I mean, pretty much it's like brand new, like this year. So they came out with the very basic stuff. So it's like motor controllers, motors, gears, sprockets, chains, you know, like axles, bearings. These are shaft clamps on the outside that holds it from shifting back and forth. They came out with, it's really cool, it's called a Versa hub. And basically what happens is it can connect to any of these. So, you know, you see how all these holes in here? It'd be able to connect to that, and then they have like a wheel that has the same connection, and then it goes together all at once. So you can just put like screws through it, and it transfers all the force. So it's pretty new. So they don't have it as extensive as stuff, but it's pretty high quality. Everything's like aluminum, and then like the gears have like I think it's like it's a ceramic coating on them, and then the aluminum axles are supposed to be like black anodized aluminum on the outside. So I did get, so this down here, as you can see, is the, would be able to rotate, but I decided last night as I was trying to connect it to this, that the plastic wasn't going to be able to hold the weight. Because, you know, even as it is, you know, like, the metal's pretty strong, but it's under a lot of force. Each motor weighs about a pound, and then, you know, this weight probably weighs about a pound, and then all the aluminum together weighs a bunch. You know, I did, you know, when I did my design, I was like, okay, aluminum would probably be really good. It's really strong and light and light, so I'll be able to, you know, like cut it and like make it however I want it to, like however long, and it'll be pretty strong, but also pretty light. But you know, it adds up, you know, 1.5 foot here, 1.5 foot here, and 1.5 foot here, times 2 for the other side. You know, it adds up pretty quickly, and so it weighs a good amount. So you know, like that's one of the things I would change if I went back and did it again. You know, these are 1.5 foot. I'd probably make them like a foot. You know, it wouldn't reach as long, but at the same time, it'd be smaller, more compact. I could get smaller motors, smaller gear ratios. Everything would be a lot smaller, a lot less weight. But yeah, I thought about making it rotate. You know, like that'd be awesome. You know, it would have been cool, but you know, like I put them together, and you know, like I attached it, and then you know, I was sitting there, I was thinking about it, and I was like, "There's no way that plastic's going to hold itself together."
We really had to last till the end of this block.
It's true, but you know, yeah. Well, the problem is, you know, like it's pretty strong. You know, like it could hold like the pressure pushing down on it, but you know, the force of this pulling down,
Yeah.
it would just rip all the screws out.